All right. So as I said in class, we're going to be completing this first half of that worksheet that I gave you. I think I mentioned that these problems really aren't that overly difficult. At least the first 15 or so aren't too bad. It starts to get a little bit tricky as we get towards the bottom of this sheet. But I figured I'd make this video for you just so that if you had any questions, you had something to consult. So what we're doing is we're obviously finding the integral of various intervals. And we were given f of x here. I don't know why it says it's to the right. It's actually to the left. But what we need to do, obviously the interval, like we said in class, is, or rather the integral is really area underneath our curve. So one thing to keep in mind is that this shape right here is a semicircle. So as we figure out the area of each one of these sections, just remember that that is a semicircle. So this area down here, this is in a negative zone because it's beneath the x-axis. So 1/2 base times height, this is -1/2 right in here. Our next section I'll outline in pink. It's this right here. And that section, let's see, we have like a 2x2 square right here. So that's 4 plus, let's see, looking at this triangle here, this is 1/2 base, which is 1. 1/2 times 2 is 1. Times height, 1, 2, 3, 4. So 4 plus 4. And then this triangle in here, this is 1/2 base again, so 1/2 times 1, 2, 3, 4, 5, 6. 1/2 times 6 is 3, so that whole pink area is going to be worth, or valued at, 11 units squared. The next area I want us to look at is going to be, let's see, we'll do this in green, this green area in here. This is a 1x2 or 2 units squared, and then 1/2 base times height. That's also 2. So this is an area of 4. Underneath our x-axis here, this is going to be another negative area. So 1/2 base, that's 3 times height is 1. 1/2 times 3 is 1.5. So let's do this in blue. We'll say this is 1.5, and that's the negative area. And then finally, our semicircle, we'll get in pink, or we already did pink. Let's do this light blue. That's 1/2 pi r squared. 1/2 pi times our r is 2 squared. That's 4 pi divided by 2, or 2 pi. All right. And then we're going to use these values in order to complete 1 through 21 below. So number 1 says the integral of f of t dt from 4 to 4. Well, we learned in class today, if these are the same value, that's just equal to 0. From 0 to 1, that's easy. It's just this area of this rectangle here. So that is going to be equal to 2, or base times height. From 1 to 3, 1 to 3, that's this triangle, which we found earlier was also equal to 2. 0 to 3, well, we already found that. It's equal to 4. The integral from 3 to 6, we already found that too, -1.5. And notice how we flipped then 3 and 6 so that 6 is on the bottom and 3 is on top. So we're going right to left, which then changes our sign. So if I wanted to rewrite this, this is the negative interval of 3 to 6 of f of t dt, which is just equal to positive 1.5. Okay, 0 to 6, that's the same as saying 4 minus 1.5, and we get 2.5. 6 to 10, well, that's our semicircle. We found that, 2 pi. 10 to -6, same thing as what we did for problems 5 and 6. We just changed the sign on that one, so that's -2 pi. All right, moving down from 0 to 10. All we're doing is just adding everything up From 0 to 10. So 4 plus 2 pi minus 1.5, that's 2.5 plus 2 pi. Let me zoom out so you can see the graph and the integrals below. So that's 2 pi plus 2.5. And then flipped, we have 10 to 0. So again, that's just negative 2 pi minus 2.5. 0 or negative 1 to 0 rather. So negative 1 to 0. Well, you can think of this a few ways. This is a trapezoid, or just think of it as a triangle on a square, right? This is a 1 by 2 rectangle. So that's an area of 2 here. So we have an area of 2 plus this triangle here has an area of 1 because we have 1/2 base times height, or 1/2 times 1 times 2. Gives us 1, and our final answer is 3. All right, from negative 3 to 0, we already found that. That's 11. From 0 to negative 3, again, we just flip our signs. We have negative 11. From negative 4 to negative 3, we found that as well. That's negative 1/2. From negative 4 to 0, add up those two areas. 11 minus 1.5 gives us 10.5. Sorry, that keeps popping up. From negative 4 to 10, so we're looking at the entire graph here. So we have 10.5 plus 2.5 plus 2 pi. So 10.5 plus 2.5 plus 2 pi. And that gives us, let's squish it in here. We got, what is this? This is 11, 12, 13 plus 2 pi is the answer to that one. For 18, this is the absolute value from 0 to 10. So we already found that the integral from 0 to 10, which one was that? I know we did that one. That was number 10, right? Number 10. Yeah, that was number 10. And we found that to be 2 pi plus 2.5. Well, the integral of 2 pi plus 2.5, or I'm sorry, the absolute value rather of 2 pi plus 2.5 is simply 2 pi plus 2.5. So it's the same thing. This is the integral of the absolute value of f of t. Now notice that this is written slightly different from number 18. In number 18, we're taking the absolute value of the entire integral. In this one, in number 19, we're just taking the absolute value of f of t. So what that means is that anything that was once positive now becomes, I'm sorry, let me say that again. Anything that was once negative now becomes positive. So, for instance, negative 1/2 is now 1/2 plus 11 plus 4 plus 1.5 plus 2 pi. And our answer, if we simplify all of this together, oh wait, you know what? I did this wrong. This is just 0 to 10. I did it from negative 4 to 10. Let me erase that. My bad. Let's do that again. The idea remains the same though. So we're just adding everything from 0 to 10. So this is 4 plus 1.5 plus 2 pi. And that gives us 5.5 plus 2 pi. Okay? And again, this is the absolute value of negative 4 to 10. So negative 4 to 10 is 13 plus 2 pi. Well, again, this was a pretty easy one. The absolute value of 13 plus 2 pi is just 13 plus 2 pi because everything's already positive. And then last but not least, this one is 10 to negative 4 of the absolute value 2 times f of t dt. All right, this is an interesting one. What we can actually rewrite this. Let me do this in a different color so it kind of stands out a little bit. We can rewrite this. We can take this 2 out. I'm going to put the negative out here, and then I'm going to switch this so that negative 4 is on the bottom and 10 is on top. So remember, I switched my a and b values. or my left and right boundaries, and that makes the integral negative. And this is now the absolute value of f of t dt. Well, we already found from actually, did we do that? Didn't do that, did we? We didn't, so we'll have to do that now. This is -2 times, so the absolute value of f of t, again, I think I mentioned that before, we're just adding up each individual area. So like if it's a negative area, that now becomes positive because it's the absolute value of this graph. So this becomes 1/2, positive 1/2, plus 11, plus 4, plus 1.5, plus 2 pi, which is equal to -2 times, all right, let's see, 1/2 plus 1.5 is 2, plus 11 is 13, plus 4 is 17, plus 2 pi, but then we have to remember to multiply that by -2. And we get -34 minus 4 pi as our final answer. Whew. All right, so that's what I mean by those problems can be a little bit tricky. Now let's take a look at the bottom of the page. I like these kinds of problems. Kind of like fitting little puzzle pieces together. They give you certain pieces of the puzzle and you have to use these clues in order to answer these questions. So I'm gonna change the color, we'll go green. From -2 to 5, the integral f of x plus g of x dx. All right, well, we know what f of x is when we take the integral of f of x from -2 to 5. It's 18. And we know what g of x is when we go from -2 to 5. It's 5. So our answer is simply 23. It's that easy. The integral from -2 to 5 of f of x plus g of x minus h of x. It's just as easy. F of x plus g of x, we already said that was 23, minus h of x. H of x is -11, so minus -11 is plus 11, which gives us an answer of 34. Now we're going from 5 to -2, so the integral from 5 to -2 of 4g of x. This is another one of those opportunities where I recommend rewriting this. So we'll pull the 4 out here, we'll make it negative, and we'll go from -2 to 5 of g of x dx. And that equals -4 times, if we look up here, -2 to 5 of g of x is 5. That gives us 20. I'm sorry, this is so smushed together. All right, that gives us 20. Let's change colors. Go with, what the heck, let's do rainbow. -2 to 5 of g of x plus 2 dx. So the integral from -2 to 5. I'm going to rewrite this. Yeah, we have enough room. I'm going to say -2 to 5 of g of x plus, dx, sorry, can't forget that, plus the integral from -2 to 5 of 2 dx. All right, now the integral from -2 to 5 of g of x, we've said 1,000 times, is 5. And then we have 2 plus 2 times -2 to 5 is 7. So we have 5 plus 14 gives us 19. All right, same idea with this problem. This is going to be -2 to 5 of f of x, that's 18, minus 6 times the interval is 7. So you're basically finding the area underneath the horizontal line, y equals -6 rather. And we get 18 minus 42, which is equal to -24. All right, and then 27. 27 is an interesting one. Now, you'll notice that the -2 is inside the parentheses, so this shifts our interval. So this is actually equal to -2 to 5 of h of x dx. All right, well, we know what that is. That is -11. All right, so that -2 there, when it's inside the parentheses of h, or of f, or of g, or of whatever your function's called, when it's inside the parentheses, it subtracts from both your upper and bottom bounds of your interval. All right, now we're adding to, so you should know what to do. Here, let me change color again. We'll go back to pink. All right, so we're adding to, so this is -2 to 5 of g of x dx. You know what that is. That is 5. This one is 5 to 8 of f of x dx. Now notice that we're given -2 to 5 and it says that that's equal to 0. Well, I can rewrite this. I can say, I'm going to look at this big interval from -2 to 8 of f of x dx, and then I'm going to subtract off the interval from -2 to 5, which gives me the interval from 5 to 8, right? I have the big interval from -2 to 8, I'm subtracting it off from -2 to 5, and I'm left with the integral from 5 to 8. That's f of x dx. And our final answer is 0 minus 18, or -18. And then last but not least, oh, I don't know if I left myself enough room. Well, let's change the color again just in case. All right, this is the integral from 1 to 8 of f of x minus 3 plus 3 dx. So I'm going to rewrite this as the integral from -2 to 5, because remember that -3 changes the upper and lower bounds, f of x plus 3 dx. And then I can rewrite that to be -2 to 5 f of x dx plus the integral from -2 to 5 of 3 dx. And that's equal to, well, -2 to 5 of f of x is equal to 18. And I get 18. And from -2 to 5 of 3, that's just 7 times 3, or plus 21. And my final answer is 39. Poof. Okay, so that is everything. It's pretty straightforward. Try the back of this sheet. If you have any questions, make sure you stop in tomorrow during your free period, and I will see you all then. Thanks for watching this video. I'll see you tomorrow.